Hi everyone, I am Matheus Chagas and I'm going to present the work called Dealing with IoT Defiant Components, which has been made in conjunction with other colleagues from the State University of Ceará and from Atlântico Research Institute. In this presentation, I will follow these topics. First, I will present a brief introduction using a motivating example. After that, I'm going to explain the defined component problem in our solution approach, followed by the details of the executed experiments. And finally, I will conclude the presentation. As a motivating example, we presented a situation where a couple live in a smart home. Every night they put their baby to sleep and set a baby monitor to check the baby's health. The collected data is sent to a mobile application on their phones, and when the application detects an emergency, it pops up a notification that can be not visualized if the phone's owners are distracted by watching TV. In this case, the app can forward the notification to the smart TV and then the message is displayed on its screen. This motivating example happens in a smart home, which is in an Internet of Things environment composed by a set of smart devices. Smart devices are able to process information and make independent decisions. That allows IoT systems to become self-adaptive systems, which are capable of adjusting the behavior in response to changes in the environment. In the smart home example, the components from the system of systems are the baby monitor device, its smartphone application, and the smart TV. The global requirement of that SOS is to increase the chances of an emergency notification to be visualized. Those devices interact by exchanging messages via communication interface, that can be either a broker or a middle, for example. The broker performs a publish-subscribe communication, collecting data from a publisher device and sending it to the corresponding subscribers, while the middle is a software layer that manages the smart devices. These types of communication interfaces are the most commonly available IoT solutions. Messages coming from the baby monitor are classified as normal or critical. The normal ones are not alerted, while critical messages generate a smartphone notification that requires a confirmation within a time limit. So while the confirmation is not done, the baby monitor device will keep resending those messages. Additionally, the smart TV has a feature that allows messages to be shown over the broadcast TV transmission. However, it also has a local requirement of blocking messages to be displayed when it's running third-party applications. As the TV was not designed to work in conjunction with a baby monitor, it did not provide the feature of unblocking the critical messages. For this reason, the TV may not be willing to change its behavior. Then a conflict emerges when the smart TV is in the same IoT environment of the baby monitor device and its corresponding mobile app, which tries to forward the notification to the TV, but the message keeps being blocked. So in this example, the smart TV can be seen as a defined component, which is a subsystem that should change its behavior in exceptional scenarios in order to accomplish the SOS global requirement. In a previous work, a cautious adaptation solution was proposed to deal with defined components. That approach consisted of creating an aspect-oriented programming wrapper to change the component's behavior in the exceptional scenario, keeping the original behavior in the remaining situations. In that approach, the use of wrappers was appropriate since the application source code was inaccessible. However, in domains where there is another level of source code access, like IoT systems, there is usually some service APIs provided and the components communicate in a different way. So a wrapper may not be the most suitable solution for all the cases. The adaptation strategy to solve that is to force the TV to stop the application. Then, the critical messages forwarded by the smartphone can be displayed, which would increase the chance of the baby to be assisted. A possible cautious adaptation strategy would consist of a mechanism that monitors the messages exchanged by the devices, detects when an exceptional scenario happens, and then executes the required adaptation actions. That solution would be only applied for the identified exceptional scenario. In other words, it would not interfere in the original behavior of the smart devices in the remaining situations. So this work presents a new cautious adaptation strategy for IoT environments. The proposal relies on adding 3 components to a smart home environment to handle the self-adaptation of the defined component. Our solution is implemented to build the MAPE feedback control loop, since it's the most common approach for applying self-adaptation. The observer component is responsible for watching the system scenarios, so it runs the monitoring in the analysis phases. The effector is responsible for applying the adaptation actions on the components, so it performs the planning in the executing phases. Both of them execute at the same time and collaborate with each other. Finally, the configurator plays the role of knowledge base, since it contains the information about the adaptation strategies configured at the system of systems initialization. This demonstrates how the included components interact with the smart home components. Initially, the configurator receives the modeling of the scenarios in the adaptation actions. The scenarios can be either normal or exceptional, and that definition is used by the observer to monitor the system. The observer distinguishes them through the messages exchanged via the user communication interface. For each exchanged message, it compares them to the defined scenarios in order to analyze whether an adaptation is needed. As for the effector, it accesses the sequence of actions that were planned to execute the adaptation. Every time an adaptation is required, it executes the actions for the exceptional scenario that is happening. When the system returns to the normal scenario, the effector is triggered again by the observer to return the defined component to its original behavior. To evaluate our solution, two IoT environments were created, one using a communication via broker and the other one using a middleware to manage the devices. The validation was done through a proof of concept that intended to verify if the approach is feasible in an IoT context. We evaluate the following research question. Does the approach contribute to increase the chances of a critical message being seen by the parents? To perform the validation, we consider three possible scenarios. Each scenario consisted of a different probability of the smart TV being blocked to receive critical messages, favorable, medium, and critical, in which the TV has 10, 50, and 90% of chances of being blocked. For each scenario, we perform three tests with different chances of a confirmation of the critical message being seen by the parents on their smartphone. Those cases indicate when there is no need to forward the message to the TV. The chances were also 90, 50, and 10%. For each combination of those scenarios, 100 executions were performed, half of them with the proposed solution and the other half without the solution. We run the test with both the broker and the middleware. We consider an execution as successful when the critical message sent from the baby monitor device to the smartphone is confirmed by the smartphone or forwarded to the TV and confirmed that the message has been displayed on its screen. Otherwise, the execution is considered a failure. This table concentrates the output of the tests. In the favorable scenario, there was a failure in 8% of the cases at both experiments in the worst confirmation rate. With our proposed solution, both types of simulation presented a 100% success rate. As expected, the more serious the scenarios become, the more important is our solution. For example, in the critical scenario with the worst confirmation rate, there was a failure rate of 84%. That represents great risk to the baby's health. There was no block of critical message by the TV with the proposed approach. The components intervened in 82% of the times in the simulation with the broker and 70% of the times in the simulation with the middleware. That demonstrates that the proposed approach has a great influence on the success of the IoT SoS global requirement. So this work presented a new cautious adaptation strategy for IoT environments. Our main contributions were a new cautious adaptation mechanism for IoT systems, a process to instantiate the proposed approach, and two open source examples of the analyzed system, one with the broker communication and the other one with a real IoT middleware that can be reused and extended by the community. We intend to make more exhaustive and efficient tests to a better validation of the proposed solution. As future work, we also intend to extend the example with new exceptional scenarios and apply the solution to other IoT systems with different architectures. Moreover, we plan to investigate uncertainties in the context of IoT systems and propose new adaptation mechanisms. And that's it. Thank you very much for your attention.
Okay, so we are live now, so we have less than 5 minutes for some questions. Are there any questions for this paper for Matthews? So I have one question for you. So what about the scalability of the system? So how many Defiant components you can support?
That's a really interesting question. We already had uh, discussed about it, our team, and that is something that we are aware that we should explore in the new studies because we believe that there's some behaviors that were not predicted
Mhm,
just using the simulation of our experiments. It has that limitation. So we believe that when we achieve to apply our approach to a real solution, to a real system of system, we should check those those features of scalability.
good. And I think there is no questions by the moment by the audience. So, by the way, how do you manage the priority of the messages and the devices as well?
Okay. The sequence to realize that some exceptional scenario is happening, we configured the observer component
Mhm,
to monitor the message. So when it detects a specific sequence of messages,
mhm,
it it declares that some exceptional scenario is occurring, and then it triggers the effector to apply the adaptation actions.
mhm.
So the prioritization of the messages is works like this. He checks if a sequence of actions matches with a predefined sequence of actions that defines a exceptional scenario.
Mhm. And finally, it seems in your approach that the broker performed better than the middleware. Do you plan to try other brokers?
Yes, because it's something that we should explore even more because we intend to even make a more exhaustive test, repeat the test with the same components, even broker or middleware, because we believe that an empirical approach would be better for the validation.
Mhm,
So we could use some other variations of the broker components. We should use some real applications that are available on
mhm.
public repositories and so on.
Yeah, right. There is a comment from Javier Martinez on the chat that the very nice concept of global goals, that this should be enforced, maybe mandatory in the future, or maybe using standards. So you need to put more emphasis in the enforcing the global goals as something that should be mandatory in your approach.
Mm, I mean, can Javier, can you explore
Precise.
this concept or the suggestion? How can we? This is a very honest question. How can we enforce that? How can you see that we can do this?
We only have 1 minute. Let's see if Javier can react on time.
Global goal as something beneficial for society. Yeah, sure. I mean, you're, as I understand, you are saying that we should emphasize that benefit of the global goals. We should uh, uh, um give more
Yeah, great. I think
that
okay.
IoT SoS might be aware of.
Yeah,
Yeah, sure. Okay, thank you for the suggestion. We appreciate.
yeah. So we have 15 seconds left. So we need probably to close and go to the next backstage. So thank you very much for the presentation, Mateus. And if you have additional question, maybe in the